Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC of triangle ABC equals to 60 degrees. We also know that BF equals to CF equals to DF that equals to EF. So those four line segments are equal to each other, and we also know that triangle BDF, this triangle, equals to 8 square units, or the area of angle BDF is 8 square units, and the area of this triangle FEC equals to 15 square units, and we want to find out the area of this green shape that we can call it the area of quadrilateral ADEF. Okay, so first of all we will define angle ABC. This angle is B, and we will also define angle ACB. This angle is C, and we know that actually we have rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees. So this will be rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees. I will read rule number 1 again. Rule number 1 states that the sum of the angles in any triangle is equal to 180 degrees. And especially the sum of the angles in the big triangle ABC is equal to 180 degrees. So angle A that equals to 60 degrees plus angle B plus angle C equals to 180 degrees according to rule number 1. So 60 degrees, that will be question number 1. 60 degrees plus angle B plus angle C must be equal to 180 degrees according to this rule, rule number 1. Okay, 60 degrees plus angle B plus angle C must be equal to 180 degrees according to rule number 1. Here we will subtract 60 degrees from equation number 1, and we will get that B plus C equals to 180 degrees minus 60 degrees is 120 degrees. Okay, so equation number 1 states that B plus C equals to 180 degrees. Okay, so in the next step we have also rule number 2. Rule number 2 states that in front of equal sides in the triangle there are equal angles. Again, I write it down. In front of equal sides in the triangle there are equal angles. I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually, if we have a triangle ABC, that has two sides that are equal to each other, so this is triangle ABC. We know that side AB of triangle ABC equals to side AC of triangle ABC. So those two sides are equal to each other according to rule number 2. In front of equal sides there are equal angles. So we have in front of side AC we have angle ABC, and in front of side AB that equals to side AC we have angle ACB. According to rule number 2, the angles that are those two angles that are located in front of equal sides in the triangle, they are also equal to each other. That is to say, angle ABC equals to angle ACB. Okay? Those two angles are equal to each other because of the fact that AB equals to AC. Therefore, angle ABC also equals to angle ACB according to rule number 2. So actually, in triangle BDF, this triangle, we know that side BF of triangle BDF, this side is equal to side DF of triangle BDF. So those two sides in triangle BDF are equal to each other. So according to rule number 2, in front of equal sides there are equal angles. So in front of side DF we have angle B, and in front of side BF we have angle BDF. this angle, and according to rule number 2, those two angles that are located in front of equal sides, they are also equal to each other. That is to say, if this angle is B, angle BDF must be also equal to B. Okay, so angle BDF equals to B according to rule number 2. And the same thing is about triangle FEC. In triangle FEC, side FC of triangle FEC equal to side FE of this triangle. FC equals to FE, and actually in front of side FE we have angle C, and in front of side FC we have angle FEC, this angle. So according to rule number 2, those two angles that are located in front of equal sides, they are also equal to each other. So if this angle is C, this angle also must be equal to C. Okay? In the next step, we will define angle BFD, this angle is Q, and we will define angle EFC, this angle is P, and then we will express angle Q by B, and we will express angle P by C. We know that the sum of the angles, according to rule number 1, the sum of the angles in any triangle is equal to 180 degrees. So in triangle BDF, the sum of the angles is equal to 180 degrees. Okay? That is to say, angle B plus angle B plus angle Q must be equal to 180 degrees according to rule number 1. So B plus B is 2B plus Q must be equal to 180 degrees according to rule number 1. So we have this equality, 2B plus Q equals to 180 degrees. We will subtract 2B from this equality, and we will get that Q equals to 180 degrees minus 2B. Okay? Q equals to 180 degrees minus 2B. So actually we expressed angle Q by B. In the next step we will express angle P by C in the same way. We actually know that the sum of the angles in any triangle, and especially in triangle FEC, this triangle, the sum of the angles is equal to 180 degrees. That is to say, angle P plus angle C plus angle C must be equal to 180 degrees according to rule number 1. So P plus 2C equals to 180 degrees. Okay, so we have this equality that P plus 2C equals to 180 degrees. Here we will subtract 2C from this equality, and we will get that P equals to 180 degrees minus 2C. Okay, so P equals to 180 degrees minus 2C, and we have already found out that Q equals to 180 degrees minus 2B. Okay, so in the next step we will add together P and Q, and we will create equation number 2. So the value of P plus Q will be equal, according to this equality, the value of P plus Q will be equal to 180 degrees plus 180 degrees is 360 degrees minus 2C minus 2B. Okay, P plus Q equals to 360 degrees minus 2C minus 2B. Here we will take out minus 2 as a common factor of this expression, and we will get that P plus Q equals to 360 degrees minus 2 is taken out as a common factor of this expression. Inside the brackets we will have C plus B. Okay, so P plus Q equals to 360 degrees minus 2 times C plus B, or B plus C. But we have already found out, we have equation number 1, or equation number 1 is that B plus C equals to 180 degrees. Therefore, we can substitute B plus C in equation number 2. B plus C and C plus B is the same thing. We can substitute B plus C by 120 degrees. Because of the fact that according to equation number 1, P plus C equals to 120 degrees. Okay, so we will get that P plus Q equals to 360 degrees minus 2 times C plus B, or B plus C. It is the same. C plus B or B plus C equals to 180 degrees, 120 degrees according to this equation number 1. So we substitute C plus B by 120 degrees. So according to equation number 2, P plus Q equals to 360 degrees minus 2 times 120 degrees is 240 degrees. So in total we got that P plus Q equals to 360 degrees minus 240 degrees. 360 degrees minus 240 degrees is 120 degrees. So actually we have two equations, that B plus C equals to 120 degrees and P plus Q also equals to 120 degrees. Okay, so in the next step we will find out the size of this angle. Before we will do it, we will connect together points D and E by a straight line. Okay, we connected together points D and E by a straight line. So now we will find out the size of angle DFE. The size of this angle, we will find out the size of this angle by using a third law. So rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So I write it down. The sum of the angles on a straight line is equal to 180 degrees. I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So actually BC is side of triangle ABC, and because of the fact that BC is side of triangle, one of the sides of triangle ABC, BC is a straight line. Okay, BC is a straight line. I will write it down. BC is a straight line. Therefore, we can implement rule number 3 on the straight line BC. If we focus at point F, according to rule number 3, the sum of the angles at point F on the straight line BC must be equal to 180 degrees. That is to say, what are the sum of the angles on the straight line BC if we focus at point F? The sum of the angles at point F on the straight line BC will be equal to Q plus P plus angle, this angle DFE, and according to rule number 3, the sum of the angles on the straight line BC must be equal to 180 degrees. So the sum of those three angles must be equal to 180 degrees. Okay, again, according to rule number 3, the sum of the angles on the straight line BC must be equal to 180 degrees. So that is to say Q plus P plus angle DFE must be equal to 180 degrees according to rule number 3. So here we know that Q plus P equals to 120 degrees according to equation number 2. Q plus P according to equation number 2, Q plus P equals to 120 degrees. So we can substitute Q plus P in this equality by 120 degrees according to equation number 2. And okay, we can substitute Q plus P by 120 degrees according to equation number 2, because Q plus P equals to 120 degrees. So we'll do it now. So instead of Q plus P in this equality, we will write down 120 degrees plus angle DFE must be equal to 180 degrees according to equation, according to rule number 3. Okay, 120 degrees plus angle DFE equals to 180 degrees. Here we will subtract 120 degrees in this equality and we will get the value of angle DFE, the value of this missing angle. So angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. Again, 180 degrees minus 120 degrees equals to 60 degrees. So we found out that angle DFE equals to 60 degrees. So the missing angle, this angle, angle DFE, equals to 60 degrees. Okay. In the next step, we will focus on triangle DFE. On triangle DFE, this green triangle, we know that side DF of triangle DFE equals to side EF. Therefore, according to rule number 2 that states that in front of equal sides in the triangle there are equal angles, so in front of side FE we have this angle that we will define as angle Y, and in front of side DF of triangle DFE we have angle FED, and according to rule number 2, in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides in triangle DFE must be also equal to each other. So if this angle is Y, then this angle also must be equal to Y because they are equal to each other. Okay? Now we will use rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in triangle DFE equals to 180 degrees. That is to say 60 degrees plus angle Y plus angle Y, or plus 2Y, must be equal to 180 degrees according to rule number 1. Okay. In triangle DFE, according to rule number 1, 60 degrees plus 2y must be equal to 180 degrees. Here we'll subtract 60 degrees from this equality, and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. 2y equals to 120 degrees. We will divide this equality by 2 in order to get the value of y. Y equals to 120 degrees over 2 is 60 degrees. So we found out that angle y equals to 60 degrees in its size. So here we can write down, we substitute angle y by 60 degrees. Here we have also angle y, we substitute it by 60 degrees. So we actually found out that all the angles of triangle DFE, the green triangle, are equal to each other, and all of them are equal to 60 degrees. Therefore, triangle DFE is an equilateral triangle, and in an equilateral triangle, all the sides of equilateral triangle are equal to each other. So this side DE equals to side DF equals to side EF. Actually, all the sides that I marked with 2 lines are equal to each other. So if side BF is x, then side FC also x equals to x, and if side DF equals to x, then side FE also equals to x, and side DE also equals to x. Okay. In the next step, we will find out the size of angle ADE, the size of this angle, and the size of this angle, according to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. Again, side AB of triangle ABC, or AB is one of the sides of triangle ABC, therefore AB is a straight line. Okay, so I write down that AB is a straight line. AB is a straight line. Therefore, we know that the sum of the angles on a straight line at any point is equal to 180 degrees. So if we focus at point D, the sum of the angles on a straight line AB at point D must be equal to 180 degrees. That is to say, angle B plus this angle that equals to 60 degrees plus the size of angle ADE must be equal to 180 degrees according to rule number 3. Okay, according to rule number 3, the sum of the angles on a straight line is equal to 180 degrees. That is to say, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees. Okay, so here we will subtract 60 degrees and beta and b from this equality, and we will get that angle ADE will be equal to the missing angle, angle ADE, will be equal to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, angle ADE equals to 120 degrees minus B. But according to equation number 1, we know that B plus C equals to 120 degrees. We will subtract B from equation number 1, and we will get that C equals to 120 degrees minus B. So 120 degrees minus B equals to C. Okay, according to equation number 1, so we can write here in this equality that 120 degrees minus B equals to C according to equation number 1. So from this equality we can derive that angle ADE equals to C. Okay, angle ADE equals to C. We found out that angle ADE equals to C. Angle ADE, this angle, equals to C. Okay, we will repeat on the same process on the other side of triangle ABC. Again, we know that the sum of the angles on a straight line is equal to 180 degrees. AC is one of the sides of triangle ABC, therefore AC is a straight line. Okay, AC is a straight line. Therefore, we can implement rule number 3 on the straight line AC. We know that at any point along a straight line, the sum of the angles must be equal to 180 degrees according to rule number 3. So if we focus at point E, the sum of the angles on the straight line AC at point E must be equal to 180 degrees. That is to say, C plus 60 degrees, C plus 60 degrees, plus angle, this angle, angle DAED, must be equal to 180 degrees according to rule number 3. Again, according to rule number 3, angle C plus 60 degrees plus the size of angle AED must be equal to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. And AC is a straight line, and if we focus on point E, the sum of the angles is actually C plus 60 degrees plus angle AED, and this sum must be equal to 180 degrees according to rule number 3. C plus 60 degrees plus the size of angle AED must be equal to 180 degrees because of the fact that the sum of the angles on a straight line at any point is equal to 180 degrees. And again, we will subtract 60 degrees and C from this equality, and we will get that angle AED equals to 120 degrees minus 60 degrees is 120 degrees minus C. Angle AED equals to 120 degrees minus C. And again, we have equation number 1 that states that B plus C equals to 120 degrees. According to equation number 1, here subtract B from equation number, will subtract C from equation number 1, and we will get that B equals to 120 degrees minus C. Okay, so according to equation number 1, 120 degrees minus C equals to B. So we can write in this equality that 120 degrees minus C equals to B, according to equation number 1. So from this equality, we can derive that angle AED equals to B. Again, angle AED equals to B. Okay, angle AED equals to B. So we can write here that angle AED equals to B. Okay, so in the next step we will prove that triangle ADE, this great triangle, is similar to triangle ABC. So we focus on triangles ABE and on triangle ADE. Okay, so in triangles ABC and ADE, on the big triangle, triangle ABC, and on the small triangle, upper small triangle, green triangle, triangle ADE, we know that angle AED in the small triangle is equal to angle ABC in triangle ABC, and those two angles are also equal to beta. Again, angle AEB in triangle ADE equals to angle ABC, and both those two angles are equal to beta, to B. Those two angles are equal to B, and they are equal to each other, okay? And then we have angle ADE in triangle ADE is equal to angle ACB in triangle ABC. And both those two angles are equal to C. Okay, again, angle ADE in triangle ADE is equal to angle ACB in triangle ABC, and those two angles are both equal to C. Okay, and we also have a common angle. This angle that equals to 60 degrees is a common angle because it belongs to triangle ADE, the green triangle, and also angle A that equals to 60 degrees belongs also to triangle ABC. So we can write down that angle A equals to angle A. It is a common angle. It belongs to both triangles, the big triangle and the small triangle. Okay, angle A equals to angle A. Okay, so we actually proved that all the angles in the big triangle, triangle ABC, are equal to all the angles in the small triangle, triangle ADE. Therefore, we actually proved that the big triangle, triangle ABC, is similar to the small triangle, triangle ADE. Okay, I will write it down. So triangle ABC, the big triangle, is similar to the small triangle, triangle ADE, according to angle similarity rule. I'll read again the things that I wrote. Triangle ABC is similar to triangle ADE according to angle similarity rule. Angle similarity rule states that if you prove that all the angles of one triangle are congruent to all the angles of the other triangle, then those two triangles are similar to each other. Okay, so we have rule number 4 that relates to similar triangles. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay, so I will read rule number 4 again. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually, according to rule number 4, if we divide the area of triangle ABC. This is the side of the area. This expression is actually states that is the size of triangle ABC. So this, the area of triangle ABC over the area of triangle ADE. So the ratio between the areas of those two similar triangles is equal, according to rule number 4, to the square ratio of the corresponding angles. And the square ratio of the corresponding angles is actually BC square over AD square over DE square over DE square. Again, according to rule number 4, the ratio between the areas of the big triangle ABC and the small triangle ADE that are similar triangles is equal to the square ratio of the corresponding sides. That is to say, it is equal to BC square over DE square. It is equal to BC square over DE square. That is the corresponding sides of the ratio of the square ratio of the corresponding sides is actually BC square over DE square. Okay? The relationship between the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. But what is BC square? What is BC? BC equals to x plus x, that is to say, it equals to 2x. BC equals to 2x, so BC square will be equal to 2x square. Over DE square. Over DE square. DE equals to x, so DE square equals to x square. So 2x square is actually 4x square, and 4x square over x square is 4. So regard that the ratio between the area of the big triangle ABC the ratio between the area of triangle ABC to triangle ADE equals to 4. Okay, the ratio between the area of triangle ABC to the small triangle ADE equals to 4. If we multiply this equality by the area of triangle ADE, we will get that the area of triangle ABC equals 4 times the area of triangle ADE. Again, we got this equality that states that the area of triangle ABC is 4 times bigger than the area of triangle ADE. The area of the big triangle, triangle ABC, is 4 times bigger than the area of this triangle, triangle ADE. But what is the area of quadrilateral BDEC? What is the area of this quadrilateral? Actually, the area of this quadrilateral BDEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE. Again, the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE, the small green triangle, triangle ADE, will be equal to the area of quadrilateral DBEC. Okay, so the area of quadrilateral BDEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE. Okay. Again, the area of quadrilateral PDEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, the small green triangle, triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE, so we can substitute the area of triangle ABC in this equality by 4 times the area of triangle ADE. Okay? So we'll do it now. So the area of quadrilateral BDEC equals to the area of triangle ABC, and we know that the area of triangle ABC equals to 4 times the area of the small triangle, triangle ADE. So we'll substitute the area of triangle ABC by 4 times the area of triangle ADE, minus 1 time the area of triangle ADE. So 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals to 3 times the area of triangle ADE. So the area of quadrilateral BDEC equals to 3 times the area of the small green triangle ADE. Okay, the area of quadrilateral BDEC equals 3 times the area of triangle, the small triangle, the small green triangle, triangle ADE. The small green triangle, triangle ADE. 3 times the area of this small triangle is equal to the area of quadrilateral BDEC. And we have already found out that the area of triangle ABC is 4 times bigger than the area of the small triangle, triangle ADE. Okay, so in the next step I will present to you a new formula for the area of any triangle. So actually, if we have triangle ABC, so we know that in this triangle ABC, the size of side AB of triangle ABC is A units, and the size of side AC of triangle ABC is B units, and the angle between side AB and side AC is theta. Then, according to the new formula of the area of this triangle, the area of this triangle, triangle ABC, the area of this triangle, triangle ABC, equals to A times B times sine theta over 2. Okay, that is the new formula for the area of any triangle, because triangle ABC can be any triangle. Again, the area of this triangle, triangle ABC, equals to A times B times sine theta over 2. Okay, we will use this formula in order to calculate the areas of those two triangles. Actually, we know that the area of triangle EFC equals to 15 square units, and the area of triangle DBF equals to 8 square units. But we want to find out, we will express those two areas by their formulas. And we use this formula for the area of the triangle in order to express the area of 15 square units and 8 square units by the expression of the formula of those areas. Okay? So actually we will divide the area of the big triangle over the area of the small triangle. Is actually 15 square units over 8 square units. Okay, the area of the big triangle, triangle EFC, that is 15 square units over the area of triangle DFB, that is 8 square units. So now on the other side, on the other side of the equality, we will express those two areas by the formula for the area of the triangle, by the formula that I have already shown to you, by this formula that the area of triangle ABC equals to A times B times sinus theta over 2. Okay, so actually, so what is the area of the big triangle, triangle EFC, according to the formula that I presented to you? The area of triangle EFC will be equal to x times sinus P over 2. Okay, so x times x is x squared times sine P over 2. And again we will express the area of this triangle, that is x square units, by the formula that I presented to you. So the area of triangle DBF will be equal to x times x times sine Q over 2. X times x is x squared times sine Q over 2. Okay, so here we will move these two to the numerator and x squared sine Q to the denominator, and we will get that 15 over 8 equals to 2 times x squared sine P over 2 times x squared times sine Q. Okay, So here two x square over 2x square is 1, so 2x square is cancelled. So we got that sine p over sine q equals to 15 over 8. Okay? Sine p over sine q equals to 15 over 8. But we have already found out, according to equation number 2, that q plus p equals to 180 degrees, 120 degrees. Okay, we know that q plus p equals to 120 degrees. So here we will subtract q from equation number 2, and we will get that P equals to 120 degrees minus Q. Okay, P equals to 120 degrees minus Q. So here we can substitute P by 120 degrees minus Q, because P equals to 120 degrees minus Q according to equation number 2. So we'll do it now. So instead of P, we write down that sine 120 degrees minus Q over sine Q equals to 15 over 8. Okay? We got the equality that states that sine 120 degrees minus Q over sine Q equals to 15 over 8. So in order to calculate the value of sine 120 degrees minus Q, we will use the following trigonometric identity, that for sine A minus B, sine A minus B equals to sine A cosine B minus sine B cosine A. Again, sine A minus B equals to sine A cosine B minus sine B cosine A. Cosine A. Okay? So according to this, we will express the we'll find the value of sine 100 minus 120 degrees minus q according to this trigonometric identity. So sine 120 degrees minus q will be equal to sine 120 degrees times cosine q minus sine q times cosine 120 degrees. Okay, so actually that is the value of sine 120 degrees minus q. So sine 120 degrees minus q equals to sine 120 degrees is root 3 over 2 times cosine q minus sine q and cosine 120 degrees is actually minus 1 over 2. Okay, so it is here, it is minus times minus is plus, so sine 120 degrees minus q equals to root 3 over 2 times cosine q minus times minus is plus 1 over 2 times sine q. So we found out the value of sine 120 degrees minus q, and we actually return to our original equality. We will have to divide sine 120 degrees minus q by sine q, and it equals to 15 over 8. Okay, so we will get that, so we will divide sine 120 degrees, this expression, by sine q, and then it will be equal to 15 over 8. So root 3 over 2 times cosine q. Again, we divide sine 120 degrees by sine q over sine q plus 1 over 2 sine q over sine q is actually 1, and all equals to 15 over 8. Okay, so here we have root 3 over 2 cosine q over sine q is cotangent q, plus 1 over 2, and sine q over sine q is 1, so sine q is cancelled, all equals to 15 over 8. Okay, So we actually found out that root 3 over 2 times cotangent q plus 1 over 2 equals to 15 over 8. Here we have the trigonometric identity that states that cotangent q equals to 1 over tangent q. So we'll substitute cotangent q here by 1 over tangent q. So we'll get that root 3, and instead of cotangent q, I'll write 1 over tangent q. This is 2 times tangent q. Plus 1 over 2 equals to 15 over 8. Here we'll substitute 1 over 2 from this equality. 1 over 2 is 4 over 8, so root 3 over 2 tangents q equals to 15 over 8 minus 4 over 8. 4 over 8 is 1 over 2. So root 3 over 2 tangents q equals to 15 minus 4 over 8 is 11 over 8. Okay. So here we will multiply this equality by tangent q, and we will get that (11 over 8 times tangent q equals to root 3 over 2. Okay, 11 over 8 times tangent q equals to root 3 over 2. Here we will multiply this equality by 8, and then we will divide it by 11 in order to get the value of tangent q. We will get that tangent q equals to root 3 over 2 times 8 over 11. So here 8 over 2 is 4, so I write it down. We get the tangent q equals to 4 times root 3 over 11. Okay, we found out the value of tangent q. It equals to 4 times root 3 over 11. So actually tangent q is the relationship between the sides of a right triangle. So if we have, so this expression states that if we have right triangle, this angle equals to 90 degrees, and this angle is q. The meaning of this equality, tangent q equals to 4 times root 3 over 11, that tangent q equals to the relationship between the sides that it is in front of angle q, that is 4 times root 3, over the side that is near angle q, that is 11. Here tangent q equals to 4 times root 3 over 11. Okay, again, tangent q in this right triangle equals to 4 times root 3 over 11. So we can use this right triangle in order to express the value of sine q. Okay, actually sine q is the angle that is in front of the side that is in front of angle q, that is 4 times root 3 over the hypotenuse. But what is the, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse, that is to say this hypotenuse square, equals to 4 times root 3 square plus the sum of the squares of the perpendiculars, 11 square. So that is actually the square of the hypotenuse. But we don't want the value of the square of the hypotenuse, but the value of the hypotenuse itself. So if we take a root from the square of the hypotenuse, we will find the hypotenuse itself. The root of the square of the hypotenuse, it is actually equals to the hypotenuse itself. Again, the root of the square of the hypotenuse equals to the hypotenuse itself. Okay, so here sine q equals to the angle that is in front of the side that is in front of angle q, that is 4 times root 3 over the hypotenuse, that is actually the root of 4 times root 3 square plus 11 square. 11 square is 121, and 4 times root 3 square is actually 16 times 3 is 48. So 48 plus 121 equals to the root of 169. So actually I found out that sine q equals to 4 times root 3 over root of 169. The root of 169 equals to 13. So we found out that the value of sine q equals to 4 times root 3, and the root of 169 is 13. So we found out the value of sine q. After we found out the value of sine q, we will calculate again the area of triangle BDQ according to the formula that I presented to you. The area of triangle BDF equals to x times sine q over 2. Again, the area of triangle BDF equals to x times x, that is x squared, times sine q over 2. But we know it is given us in the question that the area of triangle BDF is 8 square units. So we can write that the area of this triangle equals to 8 square units. And we have already found out that sine q equals to 4 times root 3 over 13. So we can substitute sine q in this equality by 4 times root 3 over 14. So we will get that x squared over 2 times sine q, that is 4 times root 3 over 13, equals to 8. Okay? x squared over 2 times 4 times root 13 times 4 times root 3 over 13 equals to 8. Okay, so here 4 times 4 over 2 is 2, so we get that x squared, here 4 over 2 is 2, so we get 2 times root 3 over 13 equals to 8. Okay, so we got that x squared times 2 times root 3 over 13 equals to 8. Here we divide this equality by 2 and we will get that x squared times root 3 over 13 equals to 4. Here we will multiply this equality by 13 and we will divide it by root 3. We will get that x squared equals to 13 times 4 is 52, and 52 over root 3 equals to x squared. So we found out that x squared equals to 52 over root 3. Okay? So in the next step we will calculate the area of the equilateral triangle. Triangle D is F, DEF, this green triangle, this equilateral triangle. According to the formula that I presented to you, the area of this equilateral triangle equals to x times sine 60 degrees over 2. X times x is x squared, sine 60 degrees equals to root 3 over 2, and root 3 over 2 over 2 is root 3 over 4. So in total we got that the area of the equilateral triangle DEF equals to 4 times root 3 times, again it is root 3, 4 times x squared over 4. Okay, the area of the equilateral triangle DEF equals to root 3 times x squared over 4. But we have already found out that x squared equals to 52 over 3. If x squared equals to 52 over root 3, so we can substitute x squared in this equality by 52 over root 3. Okay, so we will get that the area of triangle, the equilateral triangle DEF equals to x squared is 52 over root 3 times root 3 over 4. Okay, so the area of the equilateral triangle, this green triangle, equals to 52 over root 3 times root 3 over root 4. Times root 3 over 4. So here root 3 over root 3 is 1 and 52 over 4 is 13. So we found out that the area of the equilateral triangle DEF equals to 13 square units. Okay, and okay, so the area of this equilateral triangle, triangle DEF, equals to 13 square units. So after we found out the area of the equilateral triangle, it is very easy to calculate the area of the quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of triangle BDF, that is 8 square units, plus the area of the equilateral triangle, that is 13 square units, plus the area of triangle FEC, that is 15 square units. Okay, so the area of equilateral DBEC equals to 13, 8 plus 13 is 21, and 21 plus 15 is 36 square units. The area of quadrilateral DBEC equals to 36 square units. But we have already found out that the area of quadrilateral DBEC equals to 3 times the area of triangle ADE. And we found also that the area of triangle DBEC equals to 36 square units. Okay, so from this equality we can derive that 3 times the area of triangle ADE equals to 36 square units. Okay, 3 times the area of triangle ADE equals to 36 square units. Okay, here we will divide this equality by 3 in order to get the area of triangle ADE. So the area of triangle ADE will be equal to 36 over 3 is 12 square units. Okay, so we found out that the area of triangle ADE equals to 12 square units. Therefore, the area of the green shape ADFE, or the area of quadrilateral ADFE, so the area of quadrilateral ADFE, the green quadrilateral ADFE, will be equal to the area of triangle DFE, the equilateral triangle DFE, that is 13 square units, plus the area of triangle ADE, that is 12 square units. So 13 plus 12 is 25. So the area of equilateral ADFE equals to 25 square units. Again, the area of quadrilateral ADFE equals to 25 square units. The area of this green shape, this is the area of quadrilateral ADFE, is 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of quadrilateral ADFE, the green quadrilateral, and we know that angle BAC or triangle ABC is 60 degrees, and we also know that BF equals to CF equals to DF equals to EF, and we know that triangle BDF equals to 8 square units and triangle FEC equals to 15 square units, and we want to find out the area of the green shape ADEF. Okay, so first of all, we used rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees. Okay, and especially the sum of the angles in the big triangle ABC is equal to 180 degrees. That is to say 60 degrees plus angle B plus angle C equals to 180 degrees. Actually, we have rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees. So actually we defined angle ABC as B and angle ACB, this angle is C. And according to rule number 1, 60 degrees plus angle B plus angle C must be equal to 180 degrees. We subtracted 60 degrees from this equality, from question number 1, and we found out that B plus C equals to 120 degrees. Then we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So if we have triangle ABC and we know that AB equals to AC, according to rule number 2, angle ACB must be equal also to angle ABC. Those two angles must be equal to each other. Okay, so if we focus on triangle DBF, it is given us the question that side BF of triangle DBF equals to side DF. Therefore, in front of equal sides in the triangles, according to rule number 2, there are equal angles. Those two angles that are located in front of equal sides in triangle DBF must be also equal to each other. So if this angle is B, this angle also must be equal to B. Okay? And it is the same thing is true in triangle FEC. We know that side FC of triangle FEC equals to side FE. Those two sides are equal to each other, and in front of side FE we have angle C, and in front of side FC we have this angle. So those two angles are located in front of equal sides. Therefore, according to rule number 2, they also must be equal to each other. So if this angle is C, this angle must be equal. If this angle is C, then this angle also must be equal to C. Okay. In the next step, we define angle DFB is Q and angle EFC is P. Okay, and we know that then actually we expressed angle Q by B and angle P by C. According to the rule number 1, that states that the sum of the angles in any triangle is equal to 180 degrees. It is true especially in triangle DBF. The sum of its angles is equal to 180 degrees. That is to say, B plus B plus Q must be equal to 180 degrees, or B plus B is 2B, 2B plus Q equals to 180 degrees. So we subtracted 2B from this equality and we got that Q equals to 180 degrees minus 2B. And then the sum of the angles in triangle FEC also must be equal to 180 degrees according to rule number 1. So C plus P equals to 180 degrees, or P plus 2C equals to 180 degrees. And we subtracted 2C from this equality and we got that P equals to 120 degrees minus 2C, and Q equals to 180 degrees minus 2B. We added P to Q and we got that P plus Q equals to 180 degrees plus 180 degrees is 360 degrees, minus 2C minus 2B. Then we took out the common factor minus 2 from this expression, and we got that P plus Q equals to 360 degrees minus 2 times C plus B. But we know that B plus C, or C plus B, equals to 120 degrees. So we can substitute C plus B in equation number 2 by 120 degrees. We substituted C plus B by 120 degrees in equation number 2, and we found out that P plus Q equals to 120 degrees, and also we've already found out that B plus C equals to 120 degrees. Then we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. So if we look at side AB of triangle ABC is of course a straight line. So in any point along the straight line AB, the sum of the angles is equal to 180 degrees according to rule number 3. So if we focus at point D on the straight line AB, the sum of the angles at point D must be equal to 180 degrees. So B plus 60 degrees plus angle ADE must be equal to 180 degrees. Okay? So before we did it, actually we found out the angle DFE. We have rule number 3 that states that the sum of the angles along the straight line on a straight line equals to 180 degrees. BC is one side of triangle ABC, therefore it is of course a straight line. So at any point along the straight line BC, the sum of the angles must be equal to 180 degrees according to rule number 3. So if we focus at point P, the sum of the angles, if we focus at point F, the sum of the angles at point F along the straight line BC must be equal to 180 degrees. That is to say, Q plus P plus the side of this angle, the side angle DFE must be equal to 180 degrees. Again, Q plus P plus angle DFE must be equal to 180 degrees according to rule number 3, but we have already found out that Q plus P equals to 120 degrees. So we can substitute Q plus P in this equality by 120 degrees. Okay, so we substituted Q plus P by 120 degrees and we found out that angle DFE equals to 60 degrees. This angle DFE equals to 60 degrees. Then we connected together points D and E by a straight line. And we focused on triangle DFE. We know that the sum of the angles in any triangle, and especially in triangle DFE, must be equal to 180 degrees. So 60 degrees plus the size of this angle plus the size of this angle must be equal to 180 degrees. But we have also rule number 2. We know that DF equals to DE. Those two sides are equal to each other. So according to rule number 2, in front of equal sides in the triangle, there are equal angles. So those two sides are equal to each other. Therefore, in front of equal sides there are equal angles. So those two angles also must be equal to each other. So if one angle is y, then the other angle must be equal to y. So this angle is y and this angle is y. And we know that the sum of the angles in the triangle it equals to 180 degrees. So 60 degrees plus y equals to 120 degrees. 60 degrees plus y is 60 degrees plus 2y must be equal to 180 degrees according to rule number 1. We subtracted 60 degrees from this equality and we got that 2y equals to 120 degrees. We divided this equality by 2 and we got that angle y equals to 60 degrees. So we found out that those two angles that are equal to y are equal to 60 degrees. Actually we found out that all the angles in triangle DFE are equal to each other and then they are equal to 60 degrees. Therefore, triangle DFE is an equilateral triangle, and in an equilateral triangle all the sides are equal to each other. So if this side is x, then this side is x and this side is also equal to x, and those sides are also equal to x because all the sides are equal to each other. And in the next step we found out the sizes of these two angles according to rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. AB is a straight line because it is one of the sides of triangle ABC. Therefore, if we focus at point D, the sum of the angles at point D of the straight line AB must be equal to 180 degrees. So angle beta, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees. Again, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 3. Here we subtracted beta, we subtracted B at 60 degrees from this equality and we got that angle ADE equals to 180 degrees minus B. But we know according to equation number 1 that B plus C equals to 120 degrees. We subtracted B from equation number 1 and we got that C equals to 120 degrees minus B. So here 120 degrees minus B equals to C according to equation number 1. So from this equality we can derive that angle ADE equals to C. Angle ADE equals to C. So this angle equals to C. Then we repeated on the same process on this side of the triangle, on the other side of the triangle. again we know that AC is a straight line because it is one of the sides of triangle ABC, therefore it is a straight line. And we know that according to rule number 3, the sum of the angles on a straight line is equal to 180 degrees, therefore C plus 60 degrees plus angle AED must be equal to 180 degrees. Again, C plus 60 degrees plus angle ADE must be equal to 120 degrees. Then we subtracted 60 degrees and C from this equality, and we got that angle AED equals to 120 degrees minus C, but we know according to equation number 1 that B plus C equals to 120 degrees. We subtracted C from equation number 1 and we found out that 120 degrees minus C equals to B. So here we have 120 degrees minus C, it equals to B according to equation number 1. So we can write here B, and from this equality we can derive that angle AED equals to B. Angle AED equals to B. So angle AED equals to B. In the next step we proved that the small triangle, triangle ADE, is similar to the big triangle, triangle ABC, because in those two triangles, the small triangle ADE and the big triangle ABC, we know that angle AEB equals to angle ABC. Angle AEB equals to angle ABC. Both those two angles are equal to B, therefore they are equal to each other. Angle AEB equals to angle ABC, triangle ABC, and both those two angles are equal to B. And also angle ADE equals to angle ACB, and both those two angles are equal to C. Okay, angle ADE is equal to angle ACB, and both those two angles are equal to C. And also we have a common angle. This angle that equals to 60 degrees is a common angle. It belongs both to the small triangle, triangle ADE, and it belongs to the big triangle, triangle ABC. Therefore, we can write down that angle A equals to angle A because it is a common angle. It belongs to both triangles, the triangle ABC and the small triangle, triangle ADE. So we actually proved that all the angles in triangle ABC are congruent to all the angles in triangle ADE. Okay? Therefore, we actually proved that triangle ABC is similar to triangle ADE according to angle similarity rule. Okay? And we have also rule number 4 that states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually the area of triangle ABC over the area of triangle ADE equals to the square ratio of the corresponding equal to the equals to the square ratio of the corresponding angles equals to the square ratio of the corresponding angles, that is to say it equals to BC square over DE square. Okay, again the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. That is the meaning of rule number 4. But we know that BC equals to x plus x, that is to say BC equals to 2x. So BC square will be equal to 2x squared, that is 4x squared. DE equals to x, so DE squared equals to x squared. So 4x squared over x squared is 4. We actually found out that the ratio between the big triangle ABC to the small triangle ADE is 4, that is to say triangle ABC is 4 times bigger than triangle ADE. And we found out the area of triangle, the area of quadrilateral DBEC, the area of quadrilateral DBEC equals to the area of the big triangle, triangle ABC, minus the area of the small green triangle, triangle ADE. Again, the area of quadrilateral DBEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE. Okay, the area of quadrilateral BDEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE, but we have already found out that ABC, the area of triangle ABC equals to 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE, and 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals to 3 times the area of triangle ADE. So we found out in total that the area of quadrilateral BDEC equals to 4 times the area of triangle ADE, and the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, then I presented you a new formula for the area of any triangle. The area of any triangle according to this formula equals to A times B times sine theta over 2. Again, the area of this triangle equals to A times B times sine theta over 2. Okay? And then we use this formula in order to express the areas of those two triangles by the formula. So we know that the area of the big triangle is 15 square units and the area of the small triangle is 8 square units. So we divided the area of the big triangle by the area of the small triangle, and we know that the area of the big triangle according to the formula that I presented to you equals to x times sine p over 2. Okay, equals to x times sine p over 2, and the area of the small triangle equals to x times sine q over 2. X times x over times sine q over 2. So here in total we found that sine p over sine q equals to 15 over 8. But we know that q plus p equals to 120 degrees, and sine p over sine q equals to 15 over 8. So we subtracted q from equation number 2, and we found out that p equals to 120 degrees minus q. So we can substitute p in this equality by 120 degrees minus q, because p equals to 120 degrees minus q. We substituted p by 120 degrees minus q, and we got this equality that sine 120 degrees minus q over sine q equals to 15 over 8. Then I presented to you trigonometric identity in order to calculate the value of sine 120 degrees minus q. And according to this trigonometric identity, sine A minus B equals to sine A cosine B minus sine B cosine A. Okay, so we use this trigonometric identity in order to find out the value of sine 120 degrees minus q. Okay, and at the end we actually resolving the previous equality. We found out that tangent q equals to 4 times root 3 over 11, and we found out that sine q equals to 4 times root 3 over 13. This is the value of sine q. And then we calculated the area of the small triangle that equals to 8 square units according to the formula that I presented to you. The area of this small triangle equals to x times sine q over 2, or it equals to x squared times sine q over 2. And we have already found out that sine q equals to 4 times root 3 over 13, so we can substitute sine q by this expression, and after we substituted sine q by this expression, we found that x squared equals to 52 over root 3. Then we know that the area of the equilateral triangle equals to root 3 times x squared over 4, and we substituted the value of x squared in this equality by 52 over root 3, and we found out that the area of the equilateral triangle, this green equilateral triangle, equals to 13 square units. And we also found out that the area of quadrilateral DBEC equals to 36 square units. We also know that the area of quadrilateral DBEC equals to 3 times the area of triangle ADE. From this equality we got that 3 times ADE equals to 36. We divided this equality by 3 and we got that the area of triangle ADE equals to 12 square units, and the area of the green shape equals to the area of triangle ADE, that is 12 square units, plus the area of the equilateral triangle DFE, that is 13 square units. So in total the area of the green shape equals to the sum of those two areas, that is 12 plus 13. That is to say the area of the green shape equals to 25 square units. Okay, the area of this green shape, that is actually also quadrilateral ADEF, equals to 25 square units. Okay, thank you very much.